Welcome to CEEC Spotlight Leader Conversations, where industry collaborates on eco-efficient minerals. CEEC is a not-for-profit, and we're proud to help share the latest thinking and new innovations from around the world that can reduce mining's energy, emissions and water footprint. And thanks to our sponsors for making this possible.
So today I'm talking to Ellen Thomson, Scott Ferguson and Scott Marshall from Thermo Fisher Scientific. Scott Marshall is a field marketing manager who's been with Thermo Fisher for 15 years, and for the last 9 years has been working with miners to understand their needs and trends and designing new products to suit. Ellen Thomson recently joined Thermo Fisher as a senior product application specialist. She has over 20 years experience in the mining industry as a metallurgist, with the last 8 years in IT operational improvement roles implementing software globally. And Scott Ferguson is Senior Global Application Specialist. He's been with Thermo Fisher for 21 years in a variety of commercial, service and technical roles, and has a passion for improving throughput, recovery and efficiency of mineral processing plants through the application of sensing technologies. So I'm delighted to have you with me here today. Thank you.
Thank you. Thanks for having us.
So with COP26, there's been a keen focus by investors on net zero. What is Thermo Fisher Scientific doing in this area, and what are your thoughts on industry opportunities?
Yeah, thanks. Like so many of our customers and industry partners, Thermo Fisher's made the commitment to achieve net zero emissions by 2050. In fact, we've set a series of short-term targets by 2030 to ensure we get off to a good start and remain on track to achieve that goal. So that's Thermo Fisher as a company, but as a mining division, our focus has been on developing technologies primarily to help our customers achieve those net zero 2050 targets. One of our key focuses at the moment is on developing a technology for the mining and material handling part of the plant to give much greater visibility to the grades going into the process, the variability of those grades and the potential for sorting, and potentially to participate as part of a sorting program. We think that if the industry can come together to achieve a really strong ore sorting program that allows our miners to maximise their recovery while minimising the waste by sorting out the waste material before the grinding and processing part of the plant, we can save lots of power, and that will go a long way to helping achieve those net zero 2050 targets. Our other focus there is on grinding control, which has been a focus of ours for a little while now. We launched the PSM 500 particle size analyzer last year, and that really helps to give feedback to the grinding process. On one hand, to make sure that particles aren't too big getting into the process and thereby impacting potential recovery. But in terms of net zero, the focus is on ensuring that we're not over grinding and wasting power through that grinding and crushing kind of process.
And do you think that there's a role for CEEC to help collaborate in solutions in industry?
Yeah, absolutely. There is, I think, really important with CEEC to help link the miners with the technology producers and to help promote successful solutions, not only to the big miners, those kind of things, but it's really important that we reach miners of all different sizes so they have access to these opportunities and the information so they can achieve their net zero targets as well.
So we know that comminution is key to energy efficiency and productivity. What's the impact of new technologies in this area, and how do you think we can reduce emissions and the consumption of energy and water?
Thank you. So one of the key new industry trends is ore sorting, which involves removing waste before you grind and add water. So this trend, unfortunately, is something that has been quite slow to be adopted in the industry, and it's likely due to a lack of real understanding of ore variability and therefore the impact that an ore sorting program can have. So at Thermo Fisher, we've developed a range of commercial options to assist the customer to accurately assess the homogeneity of their ore and model the benefits and costs of an ore sorting program to develop a business case for that funding. So some of these options include factory feasibility studies or on-site trials with short-term rentals or leases using our CB Omni Agile. So really, if we can push through this barrier and quickly increase the adoption of this trend, there's a big opportunity for miners to reduce their waste and energy usage considerably. So for example, for every ton of ore that is not processed, it saves about 600 liters of water. And also for every ton of ore that is not crushed, it can lead to a considerable reduction in energy consumption. And one of the other added benefits is ore sorting has the benefit of reducing the operator's carbon footprints. Since waste is rejected at an early stage, that's reducing the energy usage and the need for tailings treatments.
So what are you most excited about in this area? For example, advances, innovations, and other new options for industry?
Yeah, so look, we're certainly seeing more demanding requirements from our customers, particularly with respect to the ore sorting. So, you know, bigger belts, lower grades, faster analysis times. So that's really pushing the technology into a new area, and so that's an exciting challenge, and certainly one that shouldn't be underestimated. If you just take copper for an example. You know, we're talking cut-off grades of 0.1, 0.2% on very big, fast-moving belts with potential segregation across that belt. So, you know, how do you, you know, confidently sort material in 15 seconds or less? You know, that's the sort of challenge we're facing. And so we need, you know, much higher specification analyzers to achieve that. So at Thermo Fisher, we're specifically developing a product to meet these demands. So we're looking at better detection systems, higher source strengths and things to be able to achieve the needs of the market. We're also excited about the growth that we see in collaboration. And so we see that now happening between suppliers of different technologies for sort of sensor fusion type arrangements. And we're particularly seeing examples at the moment of collaboration between the bulk sorting suppliers and the particle sorting suppliers. So that's something that we see as really encouraging, and yeah, we're interested to see what the outcomes are for the industry as a result of that.
I think I'll be very excited if for the adoption to really show that that we are on the trend of it being more environmentally friendly and actually having the technology to actually, you know, reduce that carbon footprint and the energy usage by getting rid of that waste and reducing also the amount of material that goes to tailings, which then is another issue that the industry deals with.
So what do you think is the future of mineral processing, you know, in the immediate future by 2030 and by 2050?
Yeah, look, there's a saying that that crisis drives innovation, and we're seeing a intersection now of multiple challenges for the industry. So the first one being the net zero challenge, and yeah, that is driving the need for critical minerals. So that's driving demand. And at the same time, the miners are dealing with the challenges of declining grades, deeper deposits, more complex ore bodies. And in addition to that, we've got the ESG challenges around, you know, minimising that energy, water, and tailings. So, you know, these are three big challenges if they were just being looked at in isolation. And we're seeing these upon us all at the same time. So it's actually a really exciting time, and the opportunity to make a difference is just huge. So that's great. And you know, we're already starting to see a shift in technologies, and you know, you can use the example of coarse particle flotation and dry stack tailings. We're seeing the adoption of those technologies really taking off now. They're not necessarily new technologies. But you know, that adoption is coming, and you know, we'd see that by 2030, you know, it's pretty unlikely that a plant would be built without those technologies in place. By 2050, you know, the challenge is so great that we can't continue to do things we are doing today, or the same way. So we'd see that the plant's going to look very, very different in future. And so from where we sort of, have our interests, we kind of see three main areas. The first one of those being, the adoption of that sensor-based ore sorting and pre-concentration. We see that being part of the design and flow sheet and economics of every new mine in future. And, by consequence, that means, for a given metal output, you've got less tonnes going through the plants, so lower grinding energy, lower water and less tailings. For sensors and sensing, we can see that there's a need for more and more measurements, faster measurements, connected sensors that are connected to each other and connected to other information systems. And, a good example of that is, at the moment, there are very limited measurements between the mine and the mill itself. And so in future, we see a lot more measurement and characterization of the material, from the blast point as it's traveling through to the plant. And that will enable not only feedback to the mine plans and the block models, but also feed forward into the plant. And then lastly, I think with the technologies that are coming, the type of measurements we see are probably going to change as well. And so when you think about things like, in situ processing and potentially dry milling and things like that, then that's potentially, driving opportunity for different measurements that maybe we're not even seeing in plants at the moment. And probably the last one, and that's one that I'm really passionate about, I guess, is that, mineral processing by its very definition is all about processing minerals and ideally processing minerals that are liberated. So, I'd love to see by 2050, the development and adoption of online mineralogy and online liberation measurements, because they could be absolute game changers for industry.
So what's your vision for potential opportunities in the future of industry?
So with the increasing demand for clean energy technologies, the world's reliance on critical minerals and materials such as copper, lithium, and rare earths are going to significantly increase. And this means that the necessity for data-led processes and insights will become increasingly important for mining companies to have that information that they require to support efficient operations. So technologies that monitor and lead to improve performance, allowing data-led decisions through such technology as digital twinning, predictive maintenance, data analysis, sensors and asset health will play a critical role in the future of the industry. So data from sensors, that is not only used for control and reporting purposes, but for looking at the asset health of your equipment and data quality checks through integrated systems. It's also becoming increasingly important that companies can demonstrate their commitment to sustainability and environmental care. So unfortunately, currently many plants do not have the systems or tools in place to effectively measure or analyze or make decisions that enable them to reduce their emissions. Therefore, compliance is often at risk. So it's going to be critical that plants have these sensors and instruments and have that data that will provide these companies with the following opportunities. So opportunities to improve ore to waste ratios in metal recovery, to lower the use of environmentally sensitive chemicals in their processing, and to maximize water and emissions efficiencies. So one of the other problems that we see in the industry, obviously, is the declining quality of resources, which means the need for data to support processing efficiencies and waste minimization will continue to increase in the future. And again, ideally, online mineralogy and liberation measurements would definitely be part of the vision for the future.
So could you share your thoughts on CEEC and potential value and opportunities you see, for example, new ideas for collaborative projects? Yeah,
look, we see CEEC as a great organisation for bringing organisations together. So, I've certainly found that you know, I guess the mission of CEEC was to bring leaders of industry together. And yeah, I think there's certainly opportunities to collaborate more in the future. I think also the grinding efficiency curves and the water efficiency curves and those initiatives have been really good from CEEC to be able to benchmark, or for sites to be able to benchmark themselves against sort of best practice.
So Scott and Ellen, thank you so much for joining me today. Got some really great insights, and it's great to hear all the work that you're doing in this area.
Thank
Thank
you
you very much. Thanks for having us.
If you've enjoyed today's conversation, get in contact, contribute your work and join CEEC's followers. You can tap into free articles, join our events online or in person, and watch and share future podcasts, videos and webinars. A big thanks to our valued sponsors and visionary volunteers, including our guests who we're interviewing, who make our work, our not-for-profit work, possible to help accelerate eco-efficient minerals. Thank you.